Now I'm going to start to talk about the redundant and improper constraint. Under what condition we have the redundant constraint or supports, or under what condition we have the improper supports or constraint. Let's first look at the redundant condition. Assume I have a beam and there is 2 pin apply on that, and then I have force F1 apply on that. If I want to draw the free body diagram of that, so it's going to be my pin, and then I have all the external forces applying on that, which is going to be F1. I don't have any external moment, so that's okay. And then I have the, let's name it A and B. Then I have then I'm gonna replace the support A with the reaction from the support. So I know that it's the pin is gonna have 2 supports, so it's gonna be AX and AY, because the point A, the pin doesn't let the A move up and down, so we restrain it, we prevent it from moving up and down by using AY. It doesn't let it to go left or right, so we just restrain it from going to left or right. We prevent it to go left or right, so we add AX. So AX doesn't let it go left or right, AY doesn't let it go up and down. The same thing for the B, so we are going to have BX and BY. Now, if you look at here, there are 4 unknown. In this case, assume we know the magnitude of F1, then AX, AY, BX, and BY are unknown. So we have 4 unknown, but only we have 3 equations. Sigma Fx is 0, sigma Fy is 0, and sigma M is 0. When we have a condition like that, that we have more unknown than the equation we have, the problem is that we cannot find the unknown because we have too many unknowns. And there's no way that we can find the unknowns because we do not have enough equations. So in these cases, when we have these cases like that, we have the redundant support, or in other words, it is indeterminate. This case that we have, if we look at it from the statics point of view, it is indeterminate. We cannot determine the AX, AY, BX, and BY with what we know from the statics. Later on in other courses we'll learn how to do that, but here in the statics, based on what we know, we cannot solve this problem. So it's going to be indeterminate for us, we cannot solve it. That's how we call it the redundant support or constraint. Another example, for example, I will say, for example, assume I have a beam that's fixed at one point, and there's a roller at the other point, and then again I have the point, the force F1. If I want to write a free body diagram for that, I draw the beam, I add all the external forces and external moments, so here only I have F1, and then I replace all the support with the reaction from that support that actually hold the object in place. So assume I have point A and point B. I know when there's a fixed support, it doesn't let the object move in the X direction, it doesn't let the object move in the Y direction, and it doesn't let it rotate. So it prevents it from moving in the X, moving in the Y and directions, and also prevents it from rotation. So I'm going to have 3 reactions, one in the X to make sure it's not moving in the X direction, one in the Y to make sure it's not moving the Y direction, and one M to make sure it's not rotating. Here at B, I have a roller. I know the roller only prevents the point B moving up and down. It doesn't restrain it from any other motion. So the only thing I'm going to put there is the BY, and to prevent it from going up and down. So again, this time I have 4 unknown. Also, I have 3 equations. Again, this is statistically indeterminate. I cannot determine all the forces, and again, it has a redundant support. So you have more supports than we need in this case. For example, in this case, if we remove the point A, where we remove the point B, still that is going to be in equilibrium. It's not going to move because the support at A doesn't let it to move in any way. The same here. If, for example, I replace the B, which is a pin, with the roller, still it's going to be in the equilibrium. It's not going to move. So we have more support than we need here. We have four elements of support, or 4 reactions. Only we need 3. Here also we have 4 reactions. All we need 3. So we have more than what we need, and that's why these two are the redundant. And because their number of unknown are more than 3, we cannot solve it, because we only have 3 equations. Sigma of x is 0, sigma of y is 0, and sigma m is 0. So we only can solve the problem if we have only 3 unknown. Which means both cases we have 4, or in other cases we may have more. For example, if I replace B with the instead of having B as a roller, if I replace it with the pin, then I'm gonna have another component here is a bx, because if it's a pin, then it doesn't let it to move in the x direction either. Then this time I'm gonna have 5 unknown, so it's even gonna get worse. Still I have 3 equations. I have 5 unknown, so I cannot solve it. So in any case that I have more support that I need, I'm gonna have the redundant constraint. The other condition is the improper constraint, and it happened when I don't have enough constraint. Unlike these 2 cases that I have more than I need, what if I have less than what I need? For example, one of the conditions that I may have less support that I need, assume all the support are parallel, or all the support interacting in some point. So one condition that I don't have enough constraint is that if all the support actually intersect in one point. So if all the reaction intersect at one point, then this is an improper condition. And the reason is that the moment about that point is always 0, so it might rotate about that point. So if all the reactions intersect at one point, it's improper. In other way, it does not prevent it from rotation. In 2D. In 3D, the same thing happened if all the reaction intersect at one single axis. It's the very same thing. The other cases that might this happen is that all the reactions going to be parallel. All the reactions are parallel. So if all the reactions are parallel, the same problem happens. For example, assume I have here, I have 3 roller, and I put a force like that, F1 on that. So if I have a point A, point B, and point C, I have a AX, I have a AY, it's a AY, BY, and CY. So I have 3 reactions in the y direction, but I don't have any reaction in the x direction. So all the reactions are parallel, so it doesn't prevent it to move in the x direction. So there's nothing to hold that beam moving from left or right. So if all the reactions are parallel, we don't have enough reactions, so it's an improper constraint. If all the reactions actually meet, all the reactions intersect at one point, again we don't have enough constraint, and it's an improper constraint. So there are two conditions: the redundant constraint when we have more constraint that we need, and then we have the improper constraint when we have less constraint that we need. In both cases, in the first cases, the object doesn't move, it's in equilibrium, but statistically we cannot solve it, or we cannot analyze it. In the second condition, if it's an improper support, then the object may not be in the equilibrium when it starts to move or rotate. So that's two different conditions that we might have with the supports.